In continuation with balancing of rotating masses, in the first video, we will be discussing balancing of several rotating masses in the same plane by graphical method. In the graphical method, what we do is we are going to first of all draw this phase diagram with all the positions of the rotating masses shown in the figure. Next, find out the centrifugal forces, that is product of mass into radius exerted by each mass on the rotating shaft. Then you are going to construct a tabular column where you are going to add all the masses, all the radius, and calculate the centrifugal forces divided by minus square. So you are going to get M1, R1, M2, R2, M3, R3, M4, R4. So then you are supposed to draw the polygon forces. Balancing force is then equal to the resultant force, but it is in the opposite direction. So after taking all the values, so from initial point FC1, FC2, FC3, FC4, it will be written, and with respect to the last point, what all we get, it will be joined to the initial point. That will be the final resultant centrifugal force which has to act. So that you are supposed to calculate. So by doing that, you'll be able to find out the resultant centrifugal force, that is M into R. So here we'll be taking an example of how to go with the calculation of the given masses and to find out the balancing mass which has to be added. So here the four masses M1, M2, M3, M4 are given, that is 200 kg, 300 kg, 240 kg and 260 kg. The corresponding radius are zero point 0.2 meter, 0.15 meter, 0.25 meter and 0.3 meter. The angle between their successive masses are 45 degrees, 75 degree, 135 degree. Find the position and magnitude of the balancing masses required if its radius of rotation is zero point 0.2 meter. So given value it is written and all the positions are drawn. So by all the positions with respect to orientation and here it is drawn. So by graphical method, here you can see the given mass, it is written in tabular column. Mass is given, radius is given, centrifugal force you are supposed to compute M1 into R1, M2 into R2, M3 into R3, M4 into R4. The corresponding values are 40, 45, 60 and 78. So their positions are written. So the as per the suitable scale is selected and you are supposed to draw based on the inclination. F1, FC1 value, based on the value select a suitable scale, draw the line AB, or you can take it as initial point OB also I can take. So OB, next FC with the required orientation you are supposed to draw. The FC of 3 in the corresponding orientation you are supposed to draw. So FC of 4 M you are supposed to take the value and as per the orientation you are supposed to draw. At last you are supposed to join the initial point, measure the line length, convert it into the scale taken so that we'll be able to get the required value. So our mass is unknown, centrifugal force here it is 23, A is measured as 23 kg per meter, mass is unknown and radius is known. So mass here you are going to get 115 kg. So theta is 180 plus of inclination, what all you are going to get with respect to horizontal. So theta dash you are going to get it as 21 degrees. So the 201 degree you are going to get. So here the mass is 115 kg and the orientation is 201 degree you are going to get. Same thing you can solve analytical method also and you can verify the answers. So the value what all you get, it must be able to get the correct. Analytical and graphical method, what all the method you use, irrespective of the answers won't be changing, answers will be same. So further, if we take the balancing of several masses rotating in different planes, so when we take uh, masses placed in different planes, Here you are supposed to consider consider the given four masses and take a reference plane. The reference plane is added between the first and second mass and the third and fourth mass, that is N and M. So out of two, you have to take a reference plane. So a reference plane towards the left it is considered as negative, towards right it is considered as positive, and the space diagram it is drawn with respect to different angular positions. So once again, to be under equilibrium, the following two conditions must be satisfied. That is, resultant force must be equal to zero, and the resultant couple must be equal to zero. So resultant force to be zero means sigma of m into r into cos theta must be equal to zero. Sum of m into r into sin theta must be equal to zero. M into r into l into cos theta is equal to zero. M into r into l into sin theta is equal to zero. So here, this is what the value must come. So once again, in my tabular column method, you can see that you're supposed to draw the tabular column. So you are supposed to take 1, 2, 3, 4 masses in between the TL and M planes. You are supposed to add the masses ML and MM. ML and MM we are supposed to take. So centrifugal force is M into omega square into R. So omega square it is divided throughout the masses. So M1 into R1 it comes to centrifugal force. Distance from the reference plane you are supposed to take. So from the reference plane towards left it is taken negative, and towards right it is considered as positive. So couple it comes M1 into R1 into L1 with negative sign. So M2 into R2 into L2 is supposed to take for the second mass. For the third mass, M3 into R3 into L3. For the capital M mass, it is M of M, Rm, Lm is supposed to take. For the fourth mass, M4, R4 into L4 is supposed to take. So here, first you are supposed to, after calculating this tabular column, first you are supposed to construct the force polygon. So force polygon, select a suitable scale. So after constructing the centrifugal force 1, 2, 3 and 4, join to the initial point. If there are two unknowns, you'll be having the orientation. Anyhow, you have to close the force polygon. Then in the couple polygon, you'll be having to find out with respect to the reference plane, the other centrifugal force. So measuring the suitable scale, take the value and compute the required mass. So in one case, you'll be finding out the one unknown value. In the second case, you'll be able to find out the other unknown value. So like this, you'll be able to compute the force and couple polygon.